In this tutorial, we'll be learning about orbital overlapping. Orbital overlap. You must know that orbital overlap always occurs only in covalent compounds, and we are required to see how the orbital overlap occurs. Now, there are basically two types of orbital overlapping. They are hidden overlap and sidewise overlap. Hidden overlapping, and the next one is sideway overlap. Now, since they occur only in covalent compounds, so it has nothing to do with ionic compounds. Now, hidden overlap and sideway overlap. Now, in layman term, you may think that hidden overlapping causes because a stronger bond to occur and sideway causes a weaker bond to occur. So this is the basis of orbital overlap. Now, let's consider a compound which has just a single bond in it. Let it be chlorine. In chlorine, since it has just single bond, so the single bond is caused due to hidden overlapping of the orbitals. Hidden overlapping of the orbitals. Now, let's consider that there are more than one bond. Let's consider a compound with a double bond. Oxygen. In oxygen, since it has two bonds, so one of the bond has hidden overlapping, one of the bond is occurred due to hidden overlapping, and the next is caused due to the side overlapping of the orbitals. Now, what does this mean? Let's read in detail. We have studied that p orbital is in this form and s orbital is in this form. So, for hidden overlapping to occur, the two s orbitals must coincide in this way. This must come from this side and this must come from this side, and hidden overlapping occurs. Same is the case for p orbital. For hidden overlapping to occur, these two must coincide in this form. So, since hidden overlapping is strong, the hidden overlapping is called sigma bond, and it is written in this form, sigma bond. And for sidewise overlapping to occur, this p must come from this side, so these two overlap. Now, since the overlapping in this case is not strong, hence it is the weaker. This is sidewise overlapping, and this is called pi bond. Now, please do not be concerned if you are very confused in this case, because it is not very important for you to understand detail about these cases. What you have to know is this. Now, I will be writing in summary of what you need to know. There are just few things that you need to know. They are hidden overlapping is strong. Hidden is strong, and since hidden is strong, it is called sigma bond. Hidden overlapping is called sigma. Hidden overlapping forms sigma bond. Hidden overlapping causes sigma bond, and sideway overlapping is weaker compared to sigma hidden overlapping, and sideway overlapping forms pi bond. So, whenever there is a compound which has just single bond between the molecules, then all this single bond is caused due to sigma bond. This is sigma bond, this is sigma bond, this is sigma bond, and this is sigma bond. But suppose we consider ethene. In ethene, the one bond is sigma and the other is pi. You can label any one as sigma or pi. It is not necessary that the upper one must be sigma. One is sigma and the other is pi. And what about in triple bond? In triple bond, one bond is sigma only. Hydrogen overlapping is occurred only once. So the one bond is sigma bond and the next two are pi. So both of these are pi. So the things you need to know here are the stronger bond is caused due to hydrogen overlapping and it is called sigma bond, and the weaker bond is caused due to side overlapping and it is called pi bond. And in any compound there must be one sigma bond. There is only one sigma bond, and when a compound has more than one bond, there is double or triple bond, then one bond is sigma bond and the rest are pi bonds. So what are the consequences of sigma and pi bonding? Due to pi bonding, ethene has this structure. Now we know that this is the molecule of ethene. Now what is its shape and what are the bond angles? Now let us consider this central carbon. This central carbon has 1 pair, 2 pair and 3 pair, 3 bond pair and 0 lone pair. So 3 bond pair and 0 lone pair means it's trigonal planar and the bond angle is 120 degree. This is the only thing you need to understand in this bond overlapping. And suppose we consider this carbon is the central carbon. So if you consider this carbon is central carbon, then it too has 3 bond pair, 1, 2 and 3 and 0 bond pair. So if you consider this carbon, then also this case is true, that is the molecule is trigonal planar and it has a bond angle of 120 degree. 120, 120, 120, 120, 120 and so on. So these are the things you need to learn in orbital overlapping. The next tutorial will be learning about other types of bond.